Hi there, and welcome back to Leanne Reads, the channel where we share powerful insights and personal growth lessons through great books. When you think of ice, you might picture a frozen drink or a hockey game. But ice is far more than that. It's Earth's natural air conditioner. In a world without ice, Henry Pollack shows us why these frozen giants matter, and what their disappearance means for all of us. If you enjoy what you hear and want to dive deeper, we've included a link to the book in the description below. Now, let's get published in 2009. A World Without Ice explores the profound consequences of climate change on our planet and humanity by analyzing the essential role of ice in Earth's climate system. Author Henry Pollack explains why ice is melting at an unprecedented pace, the cascading effects this has on life, sea levels, and global ecosystems, and outlines potential strategies for adapting to an uncertain future. Henry Pollack is a professor of geophysics at the University of Michigan. He was a member of the Intergovernmental Panel on Climate Change, IPCC, which, along with former U.S. Vice President Al Gore, was awarded the 2007 Nobel Peace Prize for efforts to raise awareness about climate change. Pollack has conducted scientific research on all 7 continents and is also the author of notable works, such as Uncertain Science, Uncertain World. Have you ever really thought about ice? Unless you live in the polar regions. Most of us encounter it only in a glass of chilled water or during a skating session at a local rink. In everyday life, this transparent, frozen substance often seems trivially overlooked. Yet beneath that simplicity lies a crucial role. From the frozen expanses at the poles to the glaciers perched high atop mountains, ice is not just scenery. It is a fundamental regulator of the global climate system. As greenhouse gas emissions drive Earth's temperatures higher, this once stable cryosphere is melting at an alarming, unprecedented rate. The chapters ahead reveal the indispensable functions of this frozen armor that blankets our planet. Ice reflects sunlight back into space, regulates the water cycle, and stabilizes global temperatures. When this fragile shield diminishes, the repercussions are unavoidable: disrupted ecosystems, rising seas, collapsing food systems, and the precarious futures of millions living in coastal regions. The journey through this book also takes us into places where ice sheets more than 3,000 meters thick preserve Earth's history. Carved valleys, jagged ridges, and towering cliffs stand as monuments sculpted by ice, both geologic marvels and testaments to millions of years of planetary evolution. If current trends continue, the next great wave of migration may not be caused by wars or political unrest, but by the cold, hard truth that many regions of the world will simply no longer be habitable. And it all begins with something deceptively small: the disappearance of the very ice that once safeguarded our planet. In 1768, a young officer of the British Royal Navy named James Cook was tasked with leading an expedition to the mysterious Terra Australis Incognita, the great unknown southern land, an empty expanse on world maps at the time. For centuries, philosophers had imagined this massive continent in the southern hemisphere as a necessary counterpart to balance the Earth. Born from the Greek notion of a perfectly symmetrical cosmos, but when Cook drew near to where legends suggested fertile lands would be, what he encountered was not greenery and soil, but an immense, silent wall of ice. And yet, the Greeks were not entirely wrong. Earth does indeed have two great poles, mirroring one another, vast frozen realms at opposite ends of the planet. But upon closer inspection, these icy worlds could not be more different. Antarctica is a true continent, lying more than 1,300 kilometers from the nearest coastline, covered by a sheet of ice more than 3,000 meters thick, resting solidly on a foundation of rock. By contrast, the Arctic hides no land beneath its surface. It is a sea of floating ice atop the Arctic Ocean, with a thickness of just 3 to 6 meters, fragile when compared to its southern counterpart. The differences extend beyond geography. Antarctic ice is largely stationary, creeping forward only 9 to 12 meters each year. The Arctic, by contrast, is a restless ocean of motion. Its drifting ice can shift 5 to 6.5 kilometers in a single day, an astonishing pace for such a colossal frozen mass. Despite their brutal conditions, both poles have long captured human curiosity and ambition. For centuries, explorers, scientists, sailors, and even military expeditions have braved their extremes. Today, that frontier is increasingly open to tourism. In the Arctic, visitors can trek across glaciers and glimpse reindeer, walruses, or polar bears in their natural environment. In Antarctica, tens of thousands of travelers arrive each year, drawn to the sight of penguins thriving in the bone-chilling cold, surrounded by awe-inspiring, untouched ice. Yet, as the number of tourists grows, a troubling question arises. Are we damaging these fragile ecosystems? So far, the answer appears to be, not significantly. The greatest threat to the poles is not from the few who set foot there, but from billions of small, seemingly harmless human actions repeated daily thousands of kilometers away, in the warmth of our own homes. Ice and the greenhouse effect. A powerful partnership shaping climate. Have you ever imagined what life would be like on Earth without ice? Beyond losing winter sports or the clink of ice cubes in a glass, the absence of ice would fundamentally alter the global climate. Ice is not just another form of water, it is a central regulator of the planet's climate system. One of ice's most unusual qualities lies in its very physics. Most liquids contract as they freeze. Water, however, expands, making ice less dense than liquid water. That is why ice floats, forming glaciers and sea ice that drift across the oceans. This buoyancy is not just a quirk of chemistry, it is a defining feature of Earth's climate. Ice also serves as a giant mirror, reflecting sunlight back into space. Anyone who has been sunburned on a snowy day understands this power of reflection. The vast sheets of ice at the poles bounce immense amounts of solar energy away from Earth, helping keep the planet cool. When ice disappears, that reflective shield weakens. Darker land and ocean surfaces absorb heat instead, accelerating warming. Alongside ice, Earth's atmosphere maintains climate balance through the greenhouse effect, the trapping of heat by certain gases. Most of the atmosphere is nitrogen and oxygen, which are poor absorbers of heat. But the tiny fraction made up of carbon dioxide and methane makes all the difference. These gases keep Earth 33 degrees Celsius warmer than it would otherwise be, a life or death margin for human survival. The problem today is not the greenhouse effect itself, but its dangerous amplification. Human industry, burning coal, oil, and natural gas has thickened this insulating blanket, trapping far more heat than Earth can safely handle. The result is rapid global warming, shrinking ice sheets, rising seas, and extreme weather. Ice and the greenhouse effect together form a powerful partnership. For millennia, they have held Earth's climate in delicate balance. But now, as both are pushed off-kilter, the climate system is entering a new and volatile chapter. Imagine traveling back 20,000 years to Europe or North America. Instead of forests, fields, and mountains, you would find yourself standing beneath a massive wall of ice 3 kilometers thick, stretching as far as the eye could see. Earth was deep in its most recent ice age, a glacial era that lasted 100,000 years and ended just 12,000 years ago. Ice ages are not rare episodes in Earth's history. Over the past 3 million years, the planet has endured at least 20 such cycles. But how do we know this? The answer lies buried beneath the oceans. Tiny marine creatures, such as foraminophora, built their shells from the chemistry of seawater. During ice ages, as vast amounts of water were locked up in glaciers, seawater became saltier and richer in certain minerals. When these creatures died, their shells accumulated in sediments on the seafloor. Layer by layer, they preserved a chemical diary of Earth's climate, which scientists can now read like the pages of an ancient archive. On land, the fingerprints of glaciers are equally clear. Ice does not simply cover the landscape, it reshapes it. As glaciers advance, they grind rock into gravel, carve valleys, and transport massive boulders. The first settlers of northern Europe and North America were astonished to find giant rocks scattered across plains, with no obvious origin, silent witnesses to glaciers that had long since retreated. Ice has also sculpted some of Earth's most iconic landscapes. Jagged mountain peaks, sweeping U-shaped valleys, and the fjords of Norway were all carved by glaciers. When the ice retreated, the sea flooded these valleys, creating the dramatic waterways we see today. Scandinavia's thousands of sparkling lakes are also glacial legacies, pools of meltwater, filling the scars left by retreating ice. Cold, relentless, and patient, ice has been one of the greatest sculptors in Earth's history. If the planet itself is a work of art, then ice is the invisible artist, chiseling away for millions of years to shape the masterpiece we inhabit. Roughly 20,000 years ago, Earth's most recent ice age began to loosen its grip. towering ice sheets slowly retreated, temperatures climbed. And over the next 10,000 to 12,000 years, the planet warmed to levels slightly higher than today. But how do we know this? What evidence allows us to peer back into climates long gone? One line of evidence lies in the annual rings of trees. Each year, a tree adds a layer of growth, wide rings in good years, when conditions were warm and moist, and narrow rings during years of drought or cold. By studying the patterns of these rings in ancient trees, scientists can reconstruct past climates stretching back hundreds, even thousands of years. Another archive of climate history lies locked in the ice sheets themselves. Each winter, new snow falls, compacts, and forms a fresh layer of ice. Thick or thin, these layers record snowfall and atmospheric conditions of that year. By drilling deep into the ice of Greenland and Antarctica, scientists can retrieve long cylinders of ice-time capsules that preserve a record of climate stretching back hundreds of thousands of years. These natural records reveal a striking trend. After the post-ice age warming, Earth gradually cooled by about 1.1 degrees Celsius until the dawn of the 20th century. But while we now have a fairly clear picture of the past, what about the future? For that, we rely on thermometers. Although the first thermometers were invented in the 1600s, systematic daily measurements did not begin worldwide until about 1850. Since then, the record has been unequivocal. Earth is heating up, and fast. Average global temperatures today are about 1 degree Celsius warmer than they were 150 years ago. In response to mounting concern, the United Nations created the Intergovernmental Panel on Climate Change, IPCC, in 1988, an international body tasked with evaluating climate research. By 2007, the IPCC concluded with confidence, global warming is not a matter of speculation, it is a fact. For most of Earth's history, climate has shifted slowly, driven by natural cycles unfolding over thousands of years. Until recently, a human lifetime passed with little noticeable change. But that pattern no longer holds. Today, climate change is racing ahead at an unprecedented pace and the cause is unmistakable: us. Human beings have always transformed their environment. Ancient forests that once covered the planet have been cleared to make way for farms, towns, and industry. With every tree cut down, carbon once stored in vegetation has been released back into the atmosphere, strengthening the greenhouse blanket that traps heat around the planet. The problem has been magnified by relentless population growth. With more than 7 billion people now on Earth, demand for land, food, and resources continues to escalate. Forests shrink, ecosystems vanish, and yet these pressures, while destructive, are not the largest driver of climate change. The most powerful force reshaping our climate is industrialization. Since the Industrial Revolution, our civilization has run on coal, oil, and natural gas. Burning these fossil fuels has unleashed billions of tons of carbon dioxide into the atmosphere. Between 1958 and 2009 alone, atmospheric CO levels climbed by 22%, a staggering surge over just half a century. This is the direct and measurable cause of modern global warming. And yet, despite decades of warnings, the world remains deeply dependent on fossil fuels. The global economy has been built around them, lifestyles shaped by their abundance. Transitioning to alternative energy is not impossible, but it is a challenge of immense scale, requiring a rethinking of how societies produce, consume, and live. Humanity's footprint on Earth is no longer just the trails of settlements, farms, or cities. It is etched into the very climate system itself, leaving behind a legacy that will echo for centuries to come. When climate change is no longer the future for many, climate change still feels abstract, something distant, belonging to decades or even centuries ahead. But the reality is far less comforting. Climate change is happening here and now, and its fingerprints are increasingly visible on both natural ecosystems and human societies. Perhaps the most tangible evidence is the rapid retreat of glaciers. These massive ice reserves are more than scenic wonders. They are lifelines, providing fresh water for millions of people in mountain valleys and fertile plains downstream. Meltwater from glaciers sustains households, irrigation, and agriculture, particularly during the warm months when crops need water the most. In the past, winter snow and rain accumulated as ice, melting gradually through spring and summer, releasing water at precisely the right time. But as the planet warms, snowfall decreases, glaciers shrink, and the seasonal rhythm of water supply falters. This is no longer a projection, it is already happening, threatening water security, livelihoods, and in some regions, sowing the seeds of conflict. Meanwhile, another consequence is unfolding on a global scale: rising seas. As the atmosphere warms, the oceans warm too, and warmer water expands. Add to this the torrents of meltwater pouring into the seas, and the pace of sea level rise accelerates. This is a profound danger for the roughly 100 million people living in low-lying coastal areas less than a meter above current sea level. Even a modest rise of a few dozen centimeters could displace millions, stripping away homes and farmland and triggering waves of climate refugees. Managing such a humanitarian crisis on a scale the world has never seen will be daunting, for how do we resettle entire communities when their homelands vanish beneath the waves? Can humanity stop global warming, altogether halt the melting of the polar ice caps, and prevent the seas from encroaching on coastal cities? The hard truth is, no. Even if we acted immediately, the greenhouse gases we have already released will linger in the atmosphere for a century or more. That legacy alone guarantees additional warming of at least 0.5 degrees Celsius, enough to transform fertile breadbaskets like America's Great Plains into parched landscapes. This is not a remote scenario. It is the delayed echo of our past emissions. Compounding the challenge, our global economy still depends heavily on fossil fuels. Coal, oil, and natural gas remain the foundation of energy production worldwide. To abandon them overnight would plunge economies into chaos. The realistic path forward is not elimination, but mitigation, slowing the pace of change and minimizing the damage. Mitigation means more than cutting emissions. It requires using energy more wisely. Every sector, from transportation to industry to daily life, can become more efficient. Hybrid cars already double fuel economy. Lighter materials and smarter design could triple it. At the same time, renewable energy, solar, wind, geothermal is no longer a dream of the future. Solar farms can generate power at scale. Windswept regions can harvest steady breezes through turbines. And the steady heat, just meters below ground, can provide clean heating and cooling. There is no single cure, no silver bullet. But taken together, incremental improvements and bold innovations can bend the curve of our future. It is about adapting, reshaping economies, and reimagining lifestyles, not to stop change entirely, but to ensure it remains within limits humanity can endure. Ice has long been Earth's silent regulator, a planetary thermostat, reflecting sunlight, stabilizing temperatures, and anchoring ecosystems. For millions of years, this frozen mantle kept the planet in balance. Today, that balance is unraveling. Human activity has thickened the greenhouse blanket overhead, and the thermostat is breaking. From tree rings to ocean sediments to deep ice cores, science has revealed the climate rhythms of Earth's past. Against this backdrop, today's changes stand out with alarming clarity, faster, sharper, and driven by human hands. Ice is melting, seas are rising, and ecosystems are under siege. Yet, despite the gravity of the challenge, hope remains. We cannot reverse what has already been set in motion, but we can choose how severe the future becomes. Through collective action, innovation, and a deeper recognition of our dependence on Earth's frozen reserves, we can soften the blows of a warming world. The lesson is stark but vital. What seems cold, distant, and silent is in fact essential to life as we know it. Its fate, and ours, are inseparably linked. Reading A World Without Ice was both eye-opening and sobering. Henry Pollack Docent, just present the science of melting glaciers and rising seas. He tells the story of ice as the silent architect of Earth's climate and the quiet guardian of our future. What struck me most was how something we often overlook: frozen water shapes nearly every aspect of life on the planet. From the stability of coastlines to the flow of rivers that feed entire civilizations. The book made me realize that climate change is not some distant threat waiting for future generations. It is happening right now, reshaping landscapes, economies, and lives. The disappearing glaciers are not abstract statistics. They are vanishing reservoirs that millions of people depend on for survival. Rising seas are not projections. They are already nibbling at coastlines, forcing communities to confront choices no one wants to make. What I appreciate most is Pollack's balance of urgency and hope. He makes it clear, that while we cannot undo all the damage, we are not powerless. Through innovation, smarter energy choices, and global cooperation, we can slow the pace of change and protect what matters most. For me, this book was more than a lesson in climate science. It was a reminder of responsibility. The ice is melting in silence, but it is sending us a loud and urgent message. Our actions matter, and the future we leave behind depends on the decisions we make today. Pollack's message is clear. While we cannot stop every change, we can slow the pace and protect our future. The story of ice is really the story of us, and it's one we cannot afford to ignore.